What's going on, y'all? Today we are going to learn how to solve exponentials by changing the base, also known as by factoring. So this concept revolves around this one fact. If my bases are the same, so let's say you got b to the x equals b to the y. So notice how both my bases are b. So the bases are equal. That just means that the exponents are also going to be equal. So in this case, b to the x is equal to b to the y. From there, you can say x is equal to y. So all revolves around this one fact. We're going to go through 4 examples in this video, and I suggest that you pause the video and you try them out on your own, especially if you see after you see the first one. But yeah, I'm just going to go ahead and go through these 4 examples. They're going to be increasing in difficulty. So if something doesn't make sense, maybe you should rewind and replay the video. Maybe get a tighter grasp on the easier questions. All right, but let's go ahead and get started with the first question. So here we have 3 to the x is equal to 9 to the x plus 2. So what we want to do is we want to change the base to the lowest possible number. So I'm going to change everything to be 3. So if we take a look, on the left side, we already have the base of 3. So this is going to be 3 to the x. And on the right-hand side, this is 9. But 9 is 3 squared. So instead of writing 9, I'm just going to write 3 squared in parentheses. And we're going to raise this to the x plus 2 power. All right. So I have 3 squared to the x plus 2. When you have a number, exponent raised to an exponent, you can multiply the exponents. So let me just write that over here. If you have a to the x raised to the y, this is going to be a to the x times y. So in our case, we have 3 to the second power times x plus 2. And now just like that, we have the same bases, so we can set the exponents equal to each other. So x is equal to 2x plus 2. All we need to do is solve for x, and we're done. So we're just going to distribute. It's going to be 2x plus 4. And now let's just get x by itself. Subtract 2x on both sides. You get negative x equals 4. So x is equal to negative 4. So that's the first question. Let's go ahead and move on to the second question. So here's the second question. 1/8 is equal to 2 to the 2x plus 3. The big concept here that you have to remember is that if you have 1 over a number, so if you have 1 over a, this is the same as writing a to the negative 1 power. To extend this, you could say if you have 1 over a to the x power, this is going to be equal to a to the negative x power. So in our case over here, we can rewrite 1 over 8 as 8 to the negative 1 power. And now 8 is just 2 to the third. So 2 to the third, all to the negative 1. And over on the right is 2 to the 2x plus 3. Now here you have a power raised to a power, so we can multiply those together. So 2 to the negative 3 is equal to 2 to the 2x plus 3. Our bases are the same, so we're going to set the exponents equal to each other. And now we just have to solve for x. So let's go ahead and subtract 3 on both sides. Get negative 6 equals 2x. Divide by 2 on both sides. You get x is equal to 3. Negative 3, sorry. So that's our second example. All right, let's go ahead and move on to example number 3. All right. So the reason why this is tricky is because it's not necessarily clear what base we're going to look for. I suggest that you kind of get familiar with some of your powers. That's maybe just going to come up with time. But if you don't have some of these memorized, what you can do is you can do prime factorization, which is also known as the tree thing. So let's go ahead and factor 243. So we have 243 up top. And now you're going to have to say what two numbers multiply to 243. And that's going to be, you could pick a lot of stuff, but I'm going to pick 81 and 3. Now 81 is 9 times 9, and 9 splits up to 3 and 3. So we're left with 5 3s. So 243 is also 3 to the 5th power. So we're going to go ahead and rewrite it as 3 to the 5th. So 243 is equal to 3 to the 5th, and it's raised to the x power. And we're going to do the same for 27. So here's 27 is 9 times 3, and 9 is 3 times 3. So 27 is equal to 3 to the 3rd power because we have 3 of 3s. So we can rewrite 27 as 3 to the 3rd. Now we have a power raised to a power, so we can multiply the powers. So this is 3 to the 5x. This is equal to 3 to the 3rd. So now all we got to do, our bases are the same, is set the exponents equal to each other. So we have 5x is equal to 3, so x is equal to 3 over 5. And here is my last example. My last example is a bit spicy. It's kind of a combination of things, plus adds a bit more. I would definitely say this is quite the spicy question. Maybe potentially fire in the hole status? I don't know. It's pretty high up there. So let's go ahead and see if we can solve this. So our first thing is that we have 1 over 4. Let's go ahead and change that to a negative exponent. We can say that this is equal to 4 to the negative 1 power. Let's rewrite this left side. 2 to the x squared plus 3x. And now we're going to have to change 4 to be 2 to the something. Well, 4 is 2 squared. So we can say this is 2 squared all to the negative 1 power. And we still got the same stuff over here. 2 to the x squared plus 3x over here. Now we have a power raised to a power. So we're going to multiply. This is 2 to the negative 2. And over here, we still have the same thing. 2 to the x squared plus 3x. So now our bases are both 2, so we can set our exponents equal to each other. So we're going to have x squared plus 3x is equal to negative 2. So now we just add 2 to both sides. 3x plus 2 equals 0. And now we can factor. It's everyone's favorite thing, factoring. So we can do x plus 2 times x plus 1 is equal to 0. So our solutions will be x equals to negative 2 and negative 1. And that is it for solving exponential equations through factoring. So I will see you in the next video.